Now people are still talking about the tremor that hit mid-morning, and as you can expect, there's plenty of video of the shaking. Earthquake swarms on the East Coast, a region historically considered stable, are suddenly experiencing a surge in seismic activity, leaving experts baffled and communities on edge. Could these tremors signal hidden fault lines awakening beneath our feet? Or is something even more alarming unfolding deep within the Earth? From mysterious underground shifts to potential connections with tectonic stress along the Appalachian Mountains will uncover what might be causing these unprecedented quakes. Is the East Coast facing a seismic future no one expected? Stay with us as we unravel the clues and explore what this could mean for millions of residents. January 27, 2025, seismic activity displayed on the earthquake 3D globe revealed a 3.1 magnitude event accompanied by minor swarming near the Java Trench. This region has been experiencing a noticeable increase in tectonic movement, with significant activity recorded along the divergent boundary between Antarctica and the Nazca Plate earlier in the day. A 5.7 and a 5.2 magnitude quake were registered within this cluster, which appears to be adding considerable strain to the nearby Peru-Chile Trench. The subduction of the Nazca Plate beneath the South American Plate remains a focal point of seismic stress. Notably, a magnitude 5.0 earthquake struck along the Peru-Chile Trench, likely triggered by the ongoing tectonic shifts along the divergent boundary. Shifting focus to North America, a 3.8 magnitude earthquake was recorded near York Harbor, Maine, earlier in the day. This tremor was felt across a broad area, a characteristic feature of seismic events east of the Rockies, where the geological composition transmits seismic waves over longer distances. In contrast, a quake of similar magnitude in California would not travel as far and would need to reach at least a magnitude of 6.0 or higher to be detected at comparable distances. Initially reported as a magnitude 4.1, the York Harbor event was later revised to 3.8. Historical data reveals that this area is no stranger to seismic activity, with the last notable event being a magnitude 3.6 earthquake in 2020. Smaller tremors, in the range of magnitude 3 to 4, have also occurred sporadically in this region, underscoring its moderate but persistent seismicity. Earthquakes in the northeastern United States, while less common than in regions like California, have a long and fascinating history. A recent seismic event marked within a blue circle serves as a reminder that this area, though not frequently active, is not immune to significant earthquakes. Historical data reveals the potential for sizable quakes in this region, even though centuries may pass between major events. One of the most notable historical quakes occurred in central New Hampshire in 1638, registering an estimated magnitude of 6.5. Such an event today would likely be felt across the entire region and could cause widespread damage. Nearly 400 years have passed since that rupture, but its legacy remains a testament to the underlying tectonic potential. Similarly, a 5.9 magnitude earthquake struck the area in 1755, closer to the location of the recent 3.8 quake. Other notable events include a 5.5 magnitude quake in 1727. These quakes serve as markers of a region that has experienced seismic unrest throughout its history. While it is impossible to predict precisely when another large earthquake might occur, the centuries that have elapsed since the last majors events raise questions about the area's seismic future. Is another significant earthquake overdue? Only time will tell. What is certain, however, is that these smaller quakes are a subtle reminder of the region's seismic potential. The eastern United States has seen its share of significant earthquakes throughout history, including areas like New York, South Carolina, and the New Madrid seismic zone. Today, these regions are heavily urbanized, with towering skyscrapers, intricate infrastructure, and densely populated cities. However, the forces of nature remain indifferent to human progress. A powerful earthquake could devastate this built environment in a matter of moments. As history has shown, large quakes have shaken the East Coast before, leaving a stark reminder that no region is entirely immune to seismic hazards. The South Carolina region, for instance, has experienced major tremors, as has the New Madrid seismic zone, which remains one of the most seismically active areas in the central United States. Recent minor activity, such as a 2.2 magnitude quake near Reno, Ohio, a lesser-known town near the West Virginia border, may seem inconsequential, but even small quakes highlight the ongoing tectonic processes beneath the surface. The New Madrid seismic zone experienced a minor 1.5 magnitude earthquake earlier this morning, adding to the recent increase in activity observed over the past few months. Historically, this region has been the site of some of the most powerful earthquakes in North America, including the catastrophic events of 1811 and 1812, which produced magnitudes estimated in the upper 7s to low 8s. Imagining an earthquake of that scale in today's world, marked by densely populated cities and advanced infrastructure, is sobering. Such a seismic event would undoubtedly bring widespread devastation, disrupting the lives of millions and reshaping the landscape of the central United States. This heightened activity in a region that hasn't seen a major earthquake in over 400 years serves as a reminder of the ever-present forces at play beneath the surface. When dormant fault lines begin to stir, they signal the potential for something far greater. Vigilance is essential in monitoring regions like this, where the historical record warns of the immense destructive power these fault systems are capable of unleashing. In another part of the country, a 4.2 magnitude earthquake struck near Clayton, Idaho, earlier today. The quake occurred near the Sawtooth Fault System, nestled between multiple fault zones. While relatively modest in magnitude, the earthquake was widely felt across the region. Idaho's rugged mountainous terrain likely limited the potential for significant damage, but the event underscores the seismic activity in this geologically dynamic area. In Yellowstone National Park, a 4.2 magnitude earthquake recorded in Idaho appeared prominently on nearby seismic stations. While this wasn't a local quake originating within Yellowstone itself, it serves as a testament to the sensitivity and range of the park's monitoring equipment. However, some stations within the network displayed inconsistent performance, with certain areas like Holes Hill and Pelican Cove showing little to no data, potentially due to improper calibration. These gaps highlight the importance of maintaining reliable seismic monitoring systems, especially in geologically active regions. Despite the proximity of the Idaho earthquake, there has been no noticeable uptick in seismic activity at Yellowstone. Occasionally, nearby events can trigger swarms within the park, but no such response was observed this time. A few minor quakes in the area preceded the Idaho tremor, but they seem unrelated and part of Yellowstone's routine background activity. Elsewhere in the Pacific Northwest, seismic activity remains relatively subdued. Small tremors continue. Along the volcanic chain of the Cascades, with Northern California reporting a mix of low-magnitude quakes, mostly in the range of 2s and 3s. Interestingly, over the past few months, several smaller quakes, particularly those around magnitude 1, had gone unreported, even though they were clearly detected on local seismographs. Recently, it seems those events have begun to be included in official records, reflecting a renewed focus on documenting all seismic activity, no matter how minor. This attention to detail is crucial for understanding the subtle shifts and pressures that can build into more significant seismic events over time. The Cascadia subduction zone continues to reveal its dynamic nature, as reflected in the latest tremor map. Recent data shows 269 instances of tremor activity, with a notable cluster appearing further north near the Seattle region in Washington. These tremors are not volcanic in origin, but occur deep within the subduction zone, approximately 35 to 45 kilometers below the surface. This activity represents the slow, low-frequency vibrations generated by the interaction of tectonic plates as they subtly shift against one another. These movements, though imperceptible to humans, are picked up by sensitive tremor monitoring equipment and serve as a reminder of the ongoing strain accumulating in the region. Between natural tectonic forces and human activity, a balance exists that can easily be disrupted. A recent 1.3 magnitude earthquake near Pinnacles occurred just minutes ago, accompanied by a few minor tremors at the Long Valley supervolcano. While no significant activity has been observed there for now, the region remains under close watch due to its geological potential. Shifting focus to Southern California, seismic activity appears minimal on the 2.5 magnitude map aside from a 2.6 quake near the Eleanor Fault. This fault system, although quiet for some time, is capable of generating powerful earthquakes, underscoring the ongoing buildup of stress across Southern California. The southern segment of the San Andreas Fault in particular is a source of concern. It has been over 300 years since the last major rupture in this area, leaving a significant amount of strain accumulated along the fault. Cities like San Diego and other parts of Southern California are at risk, as history has shown the potential for devastating quakes in this region. While current activity remains moderate, the prolonged seismic silence is a stark reminder of the dangers that could lie ahead. Beyond California, a few earthquakes have been recorded in Nevada and Texas. In the latter, a magnitude 3.0 quake near Pozos has been linked to nearby oil extraction and fracking operations. Over the past 30 days, seismic activity in this area has noticeably increased, particularly around wastewater injection sites. These human-induced adjustments to the Earth's crust, combined with the constant strain on the North American plate, create weak spots that are more prone to seismic events. Though these quakes are generally minor, they highlight the delicate balance between natural tectonic forces and human activity, a balance that can easily be disrupted. The largest earthquake recently recorded was a magnitude 5.7 along the Chile Rise, a divergent boundary where the seafloor is actively spreading. This geological activity directly influences the nearby Peru-Chile Trench, a region already experiencing seismic adjustments, as evidenced by a subsequent magnitude 4.1 quake, occurring about an hour later. The separation of the seafloor here highlights the dynamic interaction of tectonic plates, specifically the Nazca Plate being forced beneath the South American plate at this major subduction zone. The Valdivia Fracture Zone, while not marked on standard maps, plays a critical role in this process, with its shifting boundaries creating immense pressure along this fault system. This tectonic movement at the East Pacific Rise and the Chile Rise area often results in increased strain on the Peru-Chile Trench, and the recent seismic activity underscores this connection. A magnitude 5.0 quake further north along the trench serves as a reminder of the energy being transferred across these regions.